So are there any questions about this? This slide that kind of says today will be very short. We can all kind of get to lunch quickly. Don't have to leave to get a drink. You should be out of here in about 10 minutes. You can handle that. And then Friday, we're doing something different. If you come, you can actually get that 10 extra credit points because those are kind of sweet to backfill if you missed a quiz, or 10 points go towards an assignment too. That'll be in class, yeah.
We don't have the early.
We aren't going to have, no, it's going to be in class. And I recorded them too. So if you can't make it Friday, you can do the recording. And this time when I recorded, I did not put like the code words. I just forgot. So just tell me you watched it and we'll call it that. But hopefully you'll be here Friday to do that. The review, when I did it before, even to look at Unit 5 and to look at your old unit exams, which is what I do for the review for the final, doesn't take more than like 25 minutes or so. So we're kind of, this class is winding down. My other two classes, not so much. So chemistry still kind of, we're learning new stuff, but we'll wind down eventually. So that's Friday. And then remember Monday, Tuesday, Wednesday next week are finals. And there's a final schedule out. And you guys drew the long straw for this class anyway, because your final is on Wednesday, not Monday. So it kind of alternates when the class meets. And so you guys, yeah. So even though I said this class will not meet on Monday, you may have a final in another class. So don't say, well, Mrs. Snipe said, no. But your final is on the 13th. So, and I remember when I handed out the review sheets, I kind of reminded you that you can bring a single index card. It has to be handwritten to the final and all that stuff. Okay, any questions? All right. I put the little Wednesday here to remind me that this is actually where we start. We spent some time talking about climate change. There's a lot of reasons that climates on Earth would change, not due to human influence. Okay, we talked about the sun's variability, sunspot cycle. We talked about the fact that slabs of the Earth's crust have been moving, the plate tectonic issue. Okay, but again, with the human influence, perhaps, or I guess more pointedly, I'm going to still want to talk about the fact that the Earth's surface temperatures are getting warmer and warmer and warmer. And we actually talked about that a little bit on Monday. So clear back in Unit 1, we talked about this idea that within any, could be a climate system, within any system of anything, there's this thing called a positive feedback mechanism. And it goes something like this, and actually for your, this term is actually on your Unit 5 review sheet for this chapter. But what a positive feedback is basically, let's see, A occurs, okay, and A makes B occur directly, causes B to occur, and the fact that B occurred, actually B reinforces A. Okay, so actually with a positive feedback mechanism like this, A is going to be enhanced, okay, and going to get kind of gear up. Okay, so positive feedback mechanism. This actually could be a social positive feedback mechanism, or when you're training your dog, your dog does something good, you give him a treat, he does it good again, he gets the treat. To me, that's kind of a similar thing. A negative feedback mechanism then is where A occurs and B occurs because of A, and B occurs. But the thing about B is basically it has a dampening effect. Dampens A, okay? So B will dampen A, so it kind of has a petering down effect. So the positive and negative don't mean that it's something good and something bad. The positive means that A is going to be reinforced, and negative means that A is going to be petered out. So an example of global warming and a positive feedback, being a positive feedback mechanism in place, is if we hone in on just the ice-covered regions of the Earth. Okay, so a good way to kind of to read this circle up here is we could start. Let's see, what color do I want to take? Okay. We could start with this. The oceans are warmer, and because the oceans are warmer, we actually have more melting of the ice sheets. Okay. And because we have more melting of the ice sheets, one of the things about ice, and especially snow-covered ice, is it's very reflective. So with less ice, there's less reflectivity. That means, i.e., there's more absorption. I'm going to go ahead and say absorption of sun's energy, because that's what we're talking about here. More absorption of sun's energy. Okay, and if with more absorption of sun's energy, I guess that's down here, okay, that ultimately it makes it warmer. Okay, so this is a positive feedback mechanism. It's not because it's good. It just means as oceans warm, basically they're going to make, the warming is going to continue or be enhanced. Well, this is a look at, again, the Earth's surface is increasing temperature. This is an example of a negative feedback mechanism, and it goes something like this, kind of from left to right. So if we, again, go with the fact that the Earth's surface temperatures are warming, okay, with warming temperatures, you would expect more of, especially our large bodies of water, these oceans, to have more water vapor going from a liquid to a gas. Okay, more evaporation. With more evaporation, remember we said that water vapor, if it reaches a certain dew point temperature in the air and we have cloud condensation nuclei, that water vapor can actually condense and create clouds, liquid water. And the thing about clouds, one of the things we talked about, is the presence of clouds actually blocks a portion of the sun's energy to reaching the Earth. And of course, if you can successfully block a certain amount of energy from reaching the Earth, then your temperatures on Earth are going to cool. So this is actually where, if we call the first box A, okay, and if we call, the result of this is B, okay, what B does is ultimately we end up with cooling. Okay, so this would be this would say that global warming should in and of itself kind of settle down into nothing. Okay, the thing is they are both valid mechanisms, but the positive feedback mechanism is doing more ramping up than the negative feedback mechanism is to ramping us down. So again, speaking of cloud cover, okay, go back to this concept of aerosols. We talked about clear back in Unit 1. Remember, aerosols is basically suspended, something in the atmosphere that's not a gas, so it's suspended liquid or suspended particles. Okay, and I'm going to show you a picture here in a minute of China, and I'm going to show you putting out its fair share of aerosols, okay, into kind of fluming out from mainland China. So kind of like we saw with cloud cover, what aerosols would do, not to mention if they're like pollution coming from China, they will have a cooling effect. Does that mean that we should go and create smog so we can have a cooling effect to fight global warming? Probably not. So here is that picture I was talking about. Okay, here we have mainland China. I love to say mainland China. And if I were to kind of dim the lights a little bit more, you could kind of see this. But this is actually the plume of haze coming from, in the prevailing winds coming from mainland China. Crazy, crazy. So just to kind of finish up talking a little bit about the global warming, consequences of global warming, we talked about we'd have less ice cover, which can actually add to the positive feedback mechanism. Another thing is that our ocean levels are rising. And we know that, like the second bullet says, actually because we have the floats that tell us the depth of the ocean, and satellite imagery can show us that actually, especially kind of islands, sometimes what used to be an island with a certain square area now is much smaller because the oceans are rising. So the oceans rise for two reasons. One is because of ice melt, not like the stuff you put on your sidewalks when it's winter around here, but because the glaciers are going from a solid to a liquid, And then the other thing is any liquid, if you heat it up, will expand. So those two things make our sea levels rise. But this kind of emphasizes that all maritime locations are not created equal when the sea levels rise. This one right here on the left is more like our east coast. Our east coast. So if you've been on the Atlantic coast, you know that it's kind of a fun place to go swimming. You can kind of wade out and stuff like that. It's got a very gentle slope out into the Atlantic. Okay, if we compare this with this one down here, Pacific coast, which has more of an abrupt coastline, okay, you could definitely see that these guys over here on our east coast, when it comes to being concerned about the ocean, the sea level rising, they are more concerned than our California friends. Actually, that brings another point. It's been in the news that I think it's the Carolinas in their legislative body are really wanting to look at this and address global warming and rising sea levels in their 10-year plan. So I thought that's pretty cool. Sad but cool. So we looked at an ocean liner to kind of start out this chapter. And this is looking at kind of what the ocean liner is up against, or less than what it's up against. So the purple line here is kind of what the ice sheet used to be in the northern hemisphere, okay? And then this is what it was as of 2010. Okay, so that's kind of the shrinking ice sheet. NP, of course, stands for North Pole. If you've heard, and actually this has been in the news maybe the last 8 or 10, 12 months, my ears perk up when I hear new scientific information about global warming. The South Pole, as it turns out, actually the ice sheet has been increasing in size slightly. The North Pole has been shrinking. But unfortunately, I think that there's those people that want to ignore the science who just focus on the South Pole and all the other things that we know that our Earth's temperatures are increasing. It's definitely warming. So it might be hard for you to tell, okay, but those little, this is actually showing you permafrost. So again, we have a positive feedback mechanism with regard to the amount of tundra, right? We talked about that type of climate that has permafrost. As the temperatures rise, we have less permafrost. Permafrost thaws, and basically kind of like the snow melt or ice melt, that takes away some of the reflectivity in that area. More absorption, so more global warming. So that's a positive feedback mechanism for something negative. So this slide kind of ends out the course, actually. There on the left is the projected changes and probability. There on the right are examples of impacts just with regard to global warming, the last topic we talked about with regard to climate change. So that's it. 14 minutes. That's what I said. Well, I didn't say 14.